Domain Name System, or DNS. The DNS protocol converts names to IP addresses and vice versa. It also does names to names and other things as well. But it solved some of the problems of the host file because the host file was getting too big. There was at one point a single host file, and people would send their submissions to the maintainer of this host file, and the maintainer would update this host file, and then people would download copies of this host file, and it became a regular full-time job basically. And so the DNS protocol was basically invented as a solution to this problem. How do you maintain this giant host file? So it became a hierarchical database of information. It was invented in 1983 and 84 and has been in wide use since the mid-1980s. The DNS protocol operates on both UDP and TCP ports 53. UDP for your normal inquiries and TCP for your downloads of zone transfers and things like that. There are a couple of DNS security issues or concerns you need to think about. If you send spoofed responses while making a request, the DNS server might get confused and keep your entries. Basically, the way this happens is you send a request to your DNS server. Your DNS server, if it doesn't have a cache, will have to go to another server to get the information. So it sends the request. If you know where it's sending the request and you can spoof that source address, you can send a reply as if it were coming back from the server that it requested from. And if you do it fast enough, your reply will get there before the actual reply from the server it's requesting it from, and then it will get loaded in the cache of your DNS server and cause it to have incorrect data. The next concern is that alternative DNS routes can redirect all of your traffic. So it's a hierarchy, and it starts from the root servers, which delegate to servers that manage the top level domains, and those delegate to individual servers that manage domain names and things like that. If you modify the DNS route, you can redirect all of the traffic somewhere else. So some countries have done this, and such as China did this for a little bit, might still be doing it. Other countries have done this where they have created their own root servers and redirect everything. In addition to redirecting traffic from the root servers, you can also do DNS manipulation by ISPs. Your ISP controls all of your traffic. They can manipulate your traffic. So if you send a request out to a DNS server and your ISP decides to modify the DNS query or response, they can do that. Also, there is registrar-based DNS manipulation, because the registrars are where the individual domain owners have their data stored, and those could redirect and point to different places. You can also trick registrars into transferring names over to you, and it can be all kinds of a mess. So on Linux, we tend to use the BinD DNS server. Usually you'll hear about it being BinD, Bind, or Named. Anyway, there are a couple of things to think about. All host names end in a trailing dot. Normally when you see a host name, you don't put a trailing dot on it, but the DNS server knows it has a trailing dot and it puts it there. So you need to be aware of that, because Bind treats it like it should be there. Host names and IP addresses in DNS are written with the largest grouping on the right and the smallest on the left. What does that mean? Well, if you look at a name like example.com, com is a much larger grouping, and so it's on the right hand side. Example would be on the left hand side because it's smaller. So the larger it is, the further to the right. But if you think about IP addresses, something like 10.11.12.13, and you say, well, which one's the largest grouping? Well, the 10 is the largest, so it's on the left hand side. But that's not where the DNS wants to put it. It wants to put it on the right hand side. So if you were to write out your 10.11.12.13 in a DNS type format, it would actually be 13.12.11.10, and then it'd have a .inattr.arpa. So keep that in mind. Also, some types of records have a single value and some have more than one value. MX records have a priority and a value. So an MX record will take a name, usually a domain name, and then it will give you a priority, and it will also give you a host name of a machine you can talk to if you want to send your mail. In addition to that, there's things like the SOA records and other records that have multiple different pieces in them. Some of the useful packages in installing bind, well, you have bind and you have bind-utils. Bind-utils is really good. It provides all those really important tools like NSLOOKUP and dig, which are good for, well, doing DNS queries. You want those. When you are configuring your bind server or named, the main configuration file is in the etc directory, etc named.conf. So you go in there, you modify that file. Sometimes it's etc named then named.conf, but you find the file there, you modify that file, and that file lists all of the data that you need to know about. So where is the data stored? Well, the data is normally stored in the var named directory. So you have the var named data, which would be all of the zones that you control. And then you have var named slaves for all of the zones that are acting as secondary or slave zones. And those would be zones you get from somebody else. Now there is a big push for renaming things. And so while it is var named slaves right now, you'll probably find that words like master and slave will start to disappear because they have a negative connotation. So just be aware that the name might change to something like secondary or something else. What does the named.conf file look like? Well, you have different zones in there. There's lots of data in it, but you have these little entries for your individual zones. So that top one right there is for the domain.ext. So you could have a example.com zone, and then inside of it you have, well, information about that zone. This one, because we own it and we control it, we have the type as master. And then you list the file. Where's the file? Where the file is going to be called domain.ext.zone. And where would you find that? Well, you're probably going to find it in the var named maybe data directory, but you have to look at the rest of the configuration file to figure out where things are actually stored. Alright, if you look at the IP addresses, let's say we were doing something for the 10 dot range. We want to do the entire 10 dot range all in one file, which is quite a bit actually. So you might do zone 10.in-attr.arpa. And that would be the zone that you'd be doing. And you'd have it be a master because you are controlling it and configuring it. And then the file type would be, or the file name would be something like your IP address .zone. Now the file names don't have to match the backwards orientation or anything like that. So you could just put 10.0.0.0.zone. It doesn't even need to add an end in the word zone, but some editors treat different files differently depending on the extension, so that's something to keep in mind. So you have forward zones and reverse zones. A forward zone is a zone that uses names as its lookup. A reverse zone is something that goes from IP addresses back to names. So forward zones have multiple different types of records in them. So here's an example forward zone with, well, a bunch of things, a bunch of variables and stuff like that. But we can see the very top line right there is a $, then TTL 3H, which basically means your time to live for each of your entries is 3 hours. That's the default time, but it can be overridden and changed. And then you can see the @ sign. The @ sign means for the entire zone. So @in ns dns.domain.ext dot. You see that trailing dot? That's important So basically what this is a record for this zone, and this zone is defined as whatever's in the named.conf file. It's saying that the name server for this zone is dns.domain.ext. Well, you're going to need to make sure you have this dns.domain.ext defined somewhere. So we're assuming this is the domain.ext file, and you can see at the very bottom line there is a DNS in A, and then you put the IP address there. And the IP address right there is written in normal IP address format, so it'd be 10.11.12.13. No trailing dot in that one. So what you have is the word DNS in the front of that line, and then your IP address at the end. And if there is nothing after the DNS, no trailing dot, it assumes that you are just giving an address in that domain. And so if this is domain.ext, it will assume that is dns.domain.ext dot. And that would satisfy the name server record at the top with an A record at the bottom. Inside of each domain you have a start of authority type record and SOA, and each one of these records has a couple different pieces. You can see the domain that it's doing everything for is the domain.ext, and then you have this root.domain.ext. Well, what is that? That's actually an email address. You don't see the @ sign in the middle of the email address because the first dot is supposed to be replaced with an @ sign when you write the email address. So it actually be root@domain.ext dot as the email address for the administrator of that record. And then you can see the serial number. The serial number is usually written in a 4-digit year, a 2-digit month, 2-digit day, and then a serial number. So every time you make an edit to the information, you'd want the date written there, and then you start with 00, 01, 02, 03. You just count up. This would only allow up to 100 edits that day. And the serial number is used when you do zone transfers in order to figure out if the zone is already, well, if it's new or if it's the same zone. So if the serial number is the same, it will assume there are no changes and will not download the zone. So when you have your secondary servers out there, they need to make sure that the root server has serial numbers changing. The other numbers are refresh, retry, expire, default, time to live, those kinds of things. And those are all written in a number of seconds. So you can kind of get an idea of how long each one of these is. Some of the different types of records include your A records, your quad A or AAAA. You have your MX records, you have your CNAME records, your TXT records. There's all kinds of records. So you can see a couple of different examples here. The A records are for taking a name and converting it to an IPv4 address. Your quad A records take a name and convert it to an IPv6 address. Your MX record is a record that takes a name and converts it into a priority and a name, and that is for your mail exchange. So if this were for the domain.ext or example.com, if you wanted to send an email to that domain, you need to figure out where your mail server is. And so that MX record right there indicates that you would go to the mail in the domain server. So maybe mail.domain.ext, and you can see the record right above it is an A record that tells you the IP address of that. Then you have a couple of CNAME records. CNAMEs are aliases, and CNAME stands for canonical name. So you can see that POP and IMAP both map to mail, and you can see mail maps to an IP address. And then you can see under the mail, in addition to having an A record, mail also has a TXT record, and the TXT record has what is called an SPF, and this is used to indicate which machines are allowed to send mail for that domain. So if you received mail for something, and this would probably actually be in the @ but if you receive mail for a given domain, you'd want to know who is authorized to send mail. So you can do a lookup using the SPF information in a TXT record and figure out which IP addresses are allowed to send mail, and this indicates that the entire 10. Network is allowed to send mail, but nothing else. So all other ones are not allowed. You also have reverse zones. So the top part of the reverse zone looks the same. You can see it jumps down to this origin thing. So origin to specify individual pieces. This is doing the 192.168.0 range. And you can see the 192.168.0.0 is that second to the bottom line, where it is in 0 in PTR for pointer network.domain.ext dot. So it's telling you what the name of that IP address is when you do a reverse lookup. And you can see the .1 as well. The named service needs to be started in order to start listening. You can use the systemctl command to start the named server. You just type in systemctl start named.service. You can leave the .service off if you want. Other options you have is the start, stop, restart, status. And then if you want to make sure it starts at boot time, you can use enable. And then if you want to remove that, you can use the disable to remove that so it won't start at boot time. In order to make DNS available, to really make it available, the DNS server needs to be able to receive data through the firewall. You need both UDP and TCP/53. 53 is only necessary if you're doing zone transfers, but normally DNS servers should be able to do zone transfers. So you'd want to indicate who can do zone transfers. So you can add the services or the service for the server with the command firewall-cmd space --add-service equals DNS, and that will add in the service so that DNS can get through the firewall. If you want it to be permanent, you can do that same exact command with the -- permanent option, and then it will put it into the configuration file. So the next time the firewall starts up, it will add that rule in there. You can verify whether the services are present in the firewall currently with the firewall-cmd space -- all command, and that will indicate whether or not it is in the firewall. When you're troubleshooting, make sure the DNS server is set. And you can go look at the etcresolve.conf file and you will see which DNS server you have set, which is kind of important. You want to make sure you can talk to your DNS server in normal ways. You can use NSLookup, you can use ping, all kinds of things to make sure you can talk to it. Make sure the record is download okay. You can use NSLookup or dig. You can do a DNS hierarchy trace. So if you do a dig plus trace command on something, it will start from the root service and work its way down. You can figure out if you are in the DNS hierarchy. If you're not, then it's not likely anybody else will use you. You can make sure your firewall is correct. You can make sure logs look good. If you have any MX records or CNAME records, you want to make sure they point eventually to a valid A or quad A record. So CNAMEs can point to other CNAMEs and MXs can point to CNAMEs, or they can both point to A or quad A records. But eventually, if you keep resolving it, it should get to a quad A record. You want to verify the service is running. So you can use netstat, make sure it's running, and you want to make sure that any SELinux contexts are not strange. So you can go look in the var named directory and see if anything looks like it doesn't have named in it. It might not work properly. And that is it for DNS. So good luck.